What's up everybody, CP here. Welcome back to another video. Today's a special video. Today's a video I've been waiting to make for quite some time. How can you get more and more out of less and less? Today's smartphone has the same ability as military computers for 50 years with the size of an entire room. However, even after making exceptional step in classic computers and technologies since the arrival of quantum computers, there are many problems that classic computers are not been able to solve. Many geeks accept that quantum computers are the answer. There are still plenty of complex problems that are beyond the reach of even the world's most powerful computers, and there's no guarantee we will ever be able to tackle them. One problem is that the basic switching and memory units of computers, known as transistors, are now approaching the point where they will be soon be as small as individual atoms. If we want to computers that are smaller and more powerful than today's, we will soon need to do our computing in a radically different way. Entering the realm of atoms opens up powerful new possibilities in the shape of quantum computing, with processors that could work millions of times faster than ones we use today. Sounds amazing, but the trouble is the quantum computing is hugely more complex than traditional computing and operates in the wonderful world of quantum physics, where the classical sensible everyday laws of physics no longer apply. So what is quantum computing? Quantum computing aims to take advantage of the concepts of wave particle ductility. Quantum computers use qubits that exist in the both of the states simultaneously. The computer scientists that are working on quantum computers believe that in the future it could be possible to harness these mechanics and build computers that could be millions of times more efficient than everything that is available today. Quantum computing is often described as a nature. This happens as we don't clearly understand them as the mechanics under piping. The real world clearly operates at the subatomic level. At a quantum level, science fiction appears to become reality. The particle can travel backward and forward in time and teleport between two positions. Application of quantum computing: medicines and materials, supply chain and logistics, financial service, artificial intelligence. Now let's discuss how quantum computers work. The classical computers encode information in bits, where each bit can take a value of either 1 or 0. There are bits work as on or off switch that is ultimately used by the computers for making decisions. On the other hand, quantum computers are based on qubits that are operated on two key principles of quantum physics: superposition and entanglement. Superposition states that each qubit can represent a 0 and a 1 at the same time, whereas entanglement means that qubits in a superposition can be corrected with each other. That is, the state of one can depend on the state of other. When using these two together, qubits are acting as a more sophisticated switches. This enables the computer to function in a way that allows them to solve the complex problems that are unmanageable using today's computers. Let's go further and try to comprehend the scope and application of quantum computers. Digital computers use Boolean logic, the language of zeros and ones. Quantum computers replace Boolean logic with quantum law. As a result, we get a richer set of operations that allow us to do certain tasks with a fewer steps. You're probably thinking, can we play games on quantum computers? Being curious is a good thing. Creating a game for quantum computers offering an engaging way of exploring and testing their capabilities. Buying a computer typically involves starting a long and hardly stopped specification as you try to weigh a processor speed against RAM or hard drive capability against screen size. You might find yourself imagining what you might use the machine for and how well each device might serve those needs. That's it for today's video. If you like this video, smash that like button, subscribe if you aren't already, and I will see you in the next episode. I will see you in the next episode. I have clearly been being too much Netflix right now while we are stuck inside. So I will see you in the next one.